Hi, my name is Nikolay. I'm CEO and co-founder at Coroot. And today I'm going to talk about why your observability approach needs a refresh. But before, let's a few words about me. I am initially an ops guy. Some time ago, I worked as the head of infrastructure at a pretty big company. And since 2013, I try to make life of production engineers easier, but by providing better tools for observability and troubleshooting. And now we built Coroot, and it's an open source observability tool that focuses extracting answers from telemetry data. It's open source. It's already gained more than 5,000 stars on GitHub. What I'll cover today during my talk. The first one is what is observability. The next, I'll try to explain some thoughts about missing parts of observability solutions these days. And then we will think about how we can address them. And finally, I'll show you how we address them at Coroot. We try to find a solution for such problem. But let's start from the very beginning. From my perspective, observability is being answered questions about your system. How is the system performing right now? Why some requests are failing, and so on. So we should be able to find answers for these questions using our tools, using our knowledge about the system, and so on. And now let's talk about missing part. That's the key message of my talk. The first challenge I can see is that we don't have a complete observability solution. Every company, every production engineer have to build their own custom solution on top of existing building blocks. We have many tools that can help us gather telemetry data. We have a lot of databases focused on storing telemetry data, such as Prometheus, ClickHouse, and so on. We have a lot of UI tools that help us to build our dashboards, alerting rules, and so on. But we should use them to build our own solution that can help us find the root causes in our system. The key problem here is that you need to understand how to do so. And that's why I highlight this as a problem, because I believe we can try to solve. As a proof of my words, we have a lot of, today I looked at what LinkedIn thinks about observability engineering role. And as you can see, there are a lot of engineers around the globe that focused on building observability, bringing observability into their companies. And I believe it's the wrong way, because we should get some value from observability, not invest our resources into. The second challenge is that there are a lot of tools that provide us with some interface how we can deal with our telemetry data. Imagine that we have tons of logs, metrics, and traces, and the tools said, we have special query language, and you can find everything you need in your telemetry data. But the problem here is that a lot of people don't understand what they're looking for right now, because we are in the middle of incident and we just want to find the root cause and fix it. And we need some investigation path. Instead, we face just the query prompt, and we should like start from some point and drill down into the details and analyze telemetry data manually. This is the most important step of troubleshooting is still handled manually, because we just have a lot of telemetry data, and we need to somehow extract meaning in insights from that. And like the majority of attempts to bring AI into this problem end up with simpler interface to access telemetry data instead of using AI to interpret somehow telemetry data. They try to simplify like building queries to search something. And from my perspective, it doesn't bring any value into this problem. Next challenge is that our systems are getting more and more complex. I am a relatively old guy, and I worked in the field where we had pretty simple systems, and now our systems are ridiculously complex. And we need somehow to deal with that, and our observability solutions should follow the complexity. If we have hundreds of thousands of services, our observability tool, or we need to have thousands of dashboards or alerting rules. That's a problem from my perspective. Before, we just have some dedicated nodes with our monolith applications and dedicated nodes with databases. It was pretty straightforward to troubleshoot such systems, because you need to check everything related to application, like application logs, application metrics, and some node level metrics and telemetry. Then, if you identify that the problem is on the database side, check the same for database, underlying nodes, disks, and so on. Pretty simple, but for some reasons, now we have like a lot of services within our systems. They communicate with each other through the network. They communicate with distributed databases. We have a lot of dynamic nature of underlying infrastructure, such as spot nodes in the cloud. We have network attached storages, and it's pretty complex, a lot of nodes, and a lot of possible bottlenecks in such systems. So troubleshooting in such systems usually looks like we need to check the initial service, then follow the request path and check next service or database one by one. And when we have to deal with thousands of such services, we need to find a way how to automate this, because only in this way we will be able to troubleshoot within some reasonable amount of time. The next challenge is that to troubleshoot your system efficiently, you need to be an expert in observability, because there are any ways to work with a single telemetry signal, only with logs, only with traces, because each of them has advantages and disadvantages. And for example, you cannot understand the reason why any given service responds slower than usual. Traces can only show you that it does, but why it's happening, you need to use other telemetry signals, such as metrics, to check the resource consumption, check the lack of CPU time, check the network between components, and so on. So, and that's why manual troubleshooting requires from engineers to be an experts, and they should be able to explain telemetry signals and understand the meaning behind metrics. And the last one, our infrastructures are getting more and more complex. Before we had like single node for the application processes. Now we have virtual machines on top of hardware, and each virtual machine has its own operation system with the kernel. We have virtualization for hardware, for resources, for disks, for networks, and every node can bring new problems, new kind of problems. These days, we have not only VMs, but also containers inside the VMs. And it brings more and more challenging how to share resources between containers, how to distribute, for example, CPU time or memory. And this requires from engineers understand the topology of such systems and being able to understand why this particular process can experience a lack of CPU time, for example, or why the out-of-memory killer can terminate the process, and how to deal with that challenges. From my perspective, we have everything to automate the full cycle of making our system observable, starting from gathering telemetry data. Now we have eBPF that allows us to instrument almost everything without the need to change application code. And we can gather all telemetry data, logs, traces, metrics, profiles, just by installation some agent to the node. We don't need to change application code or redeploy them. Also, we believe that having precise telemetry data allows us to identify over 80% of possible root causes of issues automatically by analyzing metrics, explaining network status, explaining disk performance, explaining resource consumption and distribution. And the remaining 20% of issues we can identify by correlating events and logs with other telemetry signals. And understanding how systems are built allows us to highlight only the relevant log messages instead of trying to correlate every metrics between them with logs and traces. And I believe that knowledge about what does the particular metric mean or how to distinguish the good condition or bad condition, we can embed this right into the product, allowing developers to be focused on developing products instead of being experts in observability or how our complex system works. Next portion of good news is that we already implemented that for you, and it's open source. You can just install Coroot. It's an open source observability platform that covers the full cycle of the observability problem, from gathering telemetry data to extracting insights from them. And it's pretty important to be able to control all the cycle, because only when we try to identify the particular type of issues, we understand which type of metrics or logs or traces we need. And we can use eBPF or other methods to instrument applications and infrastructure to gather such metrics. Because, for example, you cannot use network packet rate to identify problems with the additional latency in your network, or you cannot use CPU usage or load average to find the problems with if some application is experiencing lack of CPU time. And it's really important to control everything from gathering data to analyzing data. And what's in the result? What you can achieve with using Coroot? First of all, you will have the complete service map of your infrastructure within minutes after installation. Because of eBPF, we know everything. We know how components communicate within your cluster. We know latency between them. We know the number of requests within them. We also can gather a lot of statistics about each particular container, its resource consumption, and so on. If when needed, we can look at our system as a big picture, like explaining connections between components, between applications. But if we need, we can drill down into container-to-container communications and see the detailed information about how they communicate, latency between each particular container. We can understand application level protocols between them, analyze the statuses of SQL queries or HTTP requests. It's super cool from my perspective because with BPF, it allows us to cover 100% of your infrastructure, including third-party and legacy services. Then, using a lot of precise telemetry data, we can build a model of each system. What does it mean? Model is a structure of your application as you can draw it on whiteboard. Like we have containers, a set of them is an application, it's like a Kubernetes deployment or set of Docker containers or system services. About each container, we know a lot. We can measure service level indicators such as availability and latency. We know everything about resource consumption. We know about underlying runtimes such as .NET or JVM runtime. We can understand the topology of your system, where the particular application instances run. We can capture TCP connections between them and the application level protocol within such connections. We know about DNS requests from each particular container. We can discover and capture logs and profiles of every container. So knowing this allows us not only build dashboards or set up some alerting rules. It allows us to analyze the system as an experienced engineer would. So we can check a set of hypotheses about every application and follow the dependency graph and find the root cause. Coroot also provides you with predefined inspections. Out of the box, it can monitor service level indicators and objectives such as latency or failed requests. We can see status of each dependency service. We can see the status of application instances, CPU, memory, and I/O inspections can check the status or the latency, for example, of disk your database. We also check application logs, and our agent can extract repeating patterns from them automatically. And that allows us to highlight that you need to pay some attention to this application logs because we have a few unique errors. And it allows us to, out of the box, provide you with a super efficient dashboards, like overview of your system. You will see all your applications sorted by the priority or their issues. Also, Coroot out of the box provide you with some anomaly detection. It analyzes anomalies of every application service level indicators, such as latency or error rate, and it can highlight you even slightest performance degradations or unusual latency spikes. You don't need to configure anything for that. And you will have that out of the box in a few minutes. And my favorite part of our product is anomaly explanation feature, where you can select any anomaly or any latency spike, and the Coroot will find you an explanation of possible causes of such anomaly. Here we have a screenshot of our user interface, and I selected the spike, and Coroot check the correlate all metrics of all underlying services of, in this case, service called catalog, and find that the problem is that we had a high network latency between the service and its database, and also we have some high CPU usage on the related on nodes related to one of database instance, and also we had some problem with our database volume. Coroot provides you the detailed explanation why it thinks that's the root cause. It correlated metrics, and it represented information in like in usual tracing format, where you have nested services, and you can follow the dependency graph. In this case, we have an application called Catalog. We have its latency charts, and we can see the anomaly. And now we can see the correlation with underlying components. In this case, Coroot checked latency between catalog and its database, and as you can see, it correlates with our anomaly. Then it finds the relevant log errors relevant to the anomaly on the errors chart. It went to the relevant database metrics and check latency between catalog and its database, and checked the latency of SQL queries. It also checked CPU delay metrics of DB-main that highlighted that one of the database instances is experiencing a lack of CPU time. And why it happened? Because of high CPU usage of the related node. Knowing the nature of each metric allows Coroot to explain anomalies deeper and deeper. Why we had a lack of CPU time? Because of high CPU usage. Then another possible reason of this, we could have a CPU limit, for example, and this lack of CPU time can be related to CPU throttling. But in this case, our database instance run without the limit, and in this case, it's just competition for CPU time between database and other processes on the node. And next, Coroot checked the I/O latency of the database volume, and also find correlation. So think of it like some virtual assistant followed the same path that an experienced engineer would follow, and checked like all dashboards one by one and find correlation between them. It doesn't work in a way where we try to correlate everything with everything. It understands the topology of your system and follow. And the last slide is that I ask you to give Coroot a try. We have an open source edition, which is distributed under Apache 2.0 license, truly open source license. And we also have an enterprise edition with some additional features, such as single sign-on, granular role-based access control, and AI-powered root cause analysis. And Coroot, you can run Coroot everywhere on your Kubernetes cluster, bare metal servers, VMs. Also, Coroot can instrument managed databases in AWS. Also, out of the box, Coroot provides you with advanced database monitoring for PostgreSQL, MySQL, MongoDB, Redis, and Memcache. That's it. Thank you for your attention.